Welcome to area between curves. So recall, if we take a definite integral from a to b of f of x dx, that this finds the signed area under the curve. This is the signed area under f between x equals a and x equals b. So if we had two curves, if we wish to find, say, the area between these two curves, right? If we want this area, presumably what we could do is we could find the area, all the area under F, and then subtract the part we don't want that's just under G as well, right? So this should be equal to finding the area under F and then, so in our designated, if this is our A and B, and then subtract off the area under G. Or in other words, we should have that this definite integral from A to B of this is equal to the definite integral from A to B of f of x dx minus the definite integral from A to B of g of x dx, which is equivalently the definite integral from A to B of f of x minus g of x dx. So if I wanted to find the area enclosed between y equals x minus 3, y equals 2x plus 1, and x equals 2, we could use definite integrals to do this. The very first thing we need to do, though, is just figure out precisely what region it is we're working with. So the first thing we need to do is sketch a graph to figure out what region we're working with, right? So to find the region. So if we draw this graph, x minus 3, we start at -3. And then we're going up with slope 1. So that first function, we're looking at something like this. Then y equals 2x plus 1. So y equals x minus 3, I did in purple. Y equals 2x plus 1, let's do in green. So we have a y-intercept of 1, slope of 2. So we're looking like this. And then we're also stopping at x equals 2. So x equals 2 is the vertical line that passes through x equals 2. And so the region enclosed by all of these is here. So this is the region that we're interested in, what we want to find the area of. So we know that our x values stop at x equals 2, right? So that we're going to, the right bound is x equals 2. or the upper bound, will be x equals 2. Our lower bound we need to find. So our lower bound will be this x value. So to find that, we're going to solve the system. So our system was y equals x minus 3 and y equals 2x plus 1. We can just do substitution, set these equal. We have x minus 3 equals 2x plus 1. If I subtract x from both sides and subtract 1 from both sides, we wind up getting -4 is equal to x. So this is that x is equal to -4. So we're interested in the area from x equals -4 to x equals 2 between these two functions. And then our top function will be from y equals 2x plus 1. Our bottom function will be our y equals x minus 3. I'm going to give myself a little more room. So essentially what we're looking at here is we're looking at the area. So we want the area from x equals -4. Oops. We want the area from x equals -4 to x equals 2 that's below y equals 2x plus 1 and above y equals x minus 3. So to find this area, we can just do the definite interval from -4 to 2. Those are the x boundaries, lower x and upper x, of our top equation, 2x plus 1, minus our bottom equation, x minus 3, dx. So again, we have x equals -4, who's here, to x equals 2. And then below 2x plus 1 and above x minus 3. So this was our top and our bottom. So from here, this just becomes taking the definite interval from -4 to 2 of x. 2x minus x is x, and then 1 minus -3 becomes +4 dx. And this becomes 1/2 x squared plus 4x, evaluated from -4 to 2. So we are looking at 1/2 times 2 squared plus 4 times 2 minus 1/2 times -4 squared plus 4 times -4. And that winds up giving us 18. So the area between in that region we specified is 18. We'll go ahead and do one more example. I apologize if this video is long. Let's go ahead and find the area enclosed between y equals x squared minus x minus 2 and y equals -x squared plus 3x plus 4. So again, the first thing we need to do is sketch the region. So they were looking at two parabolas. I'm going to use whether they open up or down and their x-intercepts to figure it out. So y equals x squared minus x minus 2. This factors as x minus 2 times x plus 1. So this has, it opens up and it has x-intercepts of -1 and 2. That second equation, y equals negative x squared plus 3x plus 4. This factors as we can pull out a negative out front. And then we will have x minus 4 times x plus 1. That would give us, without the negative, we'd have x squared minus 4x, sorry, minus 3x minus 4. Multiplying the negative, we get what we want. This opens down. We have the negative out front. And our x-intercepts are -1 and 4. So if we draw our picture, we'll do our first one in purple. So we have an x-intercept of -1 and 2, and we open up. So we're going to look something along the lines of this, whatever it actually is. And then I'm not so worried about y values. I'm more worried about x-intercepts at this point. And then our next one, let's do in green. We have -1 and 4 as our intercepts, and it opens down. So we're going to be something like this. And so we clearly have one intercept of x equals -1 for where these two functions cross. And then our job is to find the other one. Sometimes you have to find both. We're just lucky in that this one was right there. So we want this region. So the green function is my top. So that's our y equals -x squared plus 3x plus 4. The bottom is our y equals x squared minus x minus 2. I'm going to rewrite this one so it's easier to read. So the top is y equals -x squared plus 3x plus 4. This point here is x equals -1. This point here we need to find. It winds up being x equals 3. We would find that would be that we would solve the system y equals x squared minus x minus 2. And y equals -x squared plus 3x plus 4. So again, we can just set these equal to each other. I'm actually going to subtract them. And we're looking at 0 equals 2x squared minus 4x minus 6. That's equivalent to setting them equal to and moving everything over to one side. I just subtracted. So from here, we can factor out a 2. We have x squared minus 2x minus 3. And then that factors as x minus 3, x plus 1. Hence getting our x equals 3 and -1. So we know our bounds. So when we find our area, we're looking for the area from x equals -1 to x equals 3, which is above y equals x squared minus x minus 2, and below y equals -x squared plus 3x plus 4. So at this point, we are looking at the definite interval from -1 to 3. We do our top, -x squared plus 3x plus 4 minus the bottom, x squared minus x minus 2 dx. So this becomes the definite interval from -1 to 3 of -2x squared plus 4x plus 6 dx. And this is, we have -2/3 x cubed, raise the power and divide by the new power, plus 4/2 x squared plus 6x evaluated from -1 to 3. Plugging in 3, we have -2/3 times 3 cubed plus 4/2 is 2 times 3 squared plus 6 times 3. And then we will subtract -2/3 times -1 cubed plus 2 times -1 squared plus 6 times -1. And this winds up giving us, well, that first set of parentheses is 18. And then we are subtracting -10/3. And this is 18 times 3 would be 54 plus 10, so 64/3 or 21 1/3. So this is our area between the curves. So again, anytime we do the area between the curves, the first big step is to just draw the region and figure out where your bounds are. If the curves intersect, unless they tell us otherwise, you're looking for where the curves intersect each other.